Hello my friends, welcome again to my video channel. Today we will continue our work on the Hameg HM605. Some work is still to be done, so let's start. I will clean now the board with some EPA in this region, a toothbrush, and then I collect the dust and remedy this with a paper in the kitchen. And you see it is green, everywhere green. Don't know what it is. By the way, I see now that there are some solder connections not good. There were bridges in it. The guy before was made a bridge here from this transistor, and from this transistor there was obviously one trace deleted or so. Don't know why, what happened. We will see. But first I have to get out all the dirt. The quality of this board is bad. The traces are not fixed very well to the PCB when soldering. The pads, the wires are instantaneously removed. They break, they stick to the soldering iron, and I think that's what happened. We can see it here. This tab is missing. Also on this side here, where the PCB got a little bit hot, yes, there are some power resistors, a battery. These are the collector resistors for the output stage. The output stage has a rather high thermal dissipation. Here also the pad is missing. But this is a good opportunity now to check the transistors. They have no contact to the they are open, so I can check it with a voltmeter whether the base emitter and base collector voltages are still okay. I use this voltmeter in the setting, is it volt? Yes, I'm measuring a volt. It's overload, and it is 0. Then I go here to the base, the center pin. This is .69 and the other one .77. I think that's a what is it? 1 moment. This is the emitter. The emitter voltage is a little bit higher, base emitter voltage 0.7. There's a collector voltage, base collector. I check it on the other transistor. Okay, that's also good. And then I can check the other transistors, but I'm sure they are okay. So I have to resolder it with some wire bridges to get the final board operating again. The work on the Y board is done, but I've seen that this contact where the wires are soldered, there's also something which needs rework. Looks not so good. Someone has soldered here, but I see 1 or 2 of the wires are missing. I have to flip it around and see what I can do. Oh yeah, there are some wires broken. It is bended through under this axis through this hole where the counter plug is from the YF board, from the Y board, Y final board. But these wires here look very ugly. I have to cut them all. Maybe they have been broken when someone did a lot of work on the wire board. These wires are very in danger to be broken. They are stiff, not flexible, and they are isolated, and when they are cut here, they can break when they are moved sometimes. That's bad. I have to take it out. Well, I will do it in the brute way. I bend it sometimes until they break all, then they can solder them out pin by pin and try to solder it a little bit better. I unsolder these pins pin by pin with a tweezer. Try, of course, not to damage the board. And the quality is a mess. And then I use some solder braid or so and try to clean the tabs, the pads. To strip the isolation of the wires, I use a small knife, a cutter, feed it with very low pressure along here and on the other side. Of course, not cutting the wires itself. And then in the second step, means here and here, and in the second step I will cut between the wires. Sorry you can't see it. Cut it here and here along the wires, and here and so on, always be on both sides of the wires, so the isolation is now rather loose. And then I take a small plier and pull off these isolation between the wires, and the rest on the wires I can remove using the cutter, the ridge of the cutter, and to strip it off in this direction and on the other side also. And when you do it several times, then you will get it off, can strip it off. This whole procedure took me approximately 5 minutes, not more. And the result you can see here is a lot of small isolation pieces, and now the set of wires is ready for reinstallation. And now I'm looking for the correct wiring of the vertical deflection plates. I found under this blue heat shrink tube this construction, this original length. I think when I feed it into the CRT socket, it just reaches with this point the vertical deflection board. So this was additionally added, and you remember we had oscillations. The other connector, by the way, there are resistors 33 ohms in series. These are obviously damping resistors to prevent oscillation due to the capacitive load of the Y amplifier. Capacitive loads are not good. An inductivity is always everywhere. Each wire is an inductivity, and when we have a broadband amplifier which has a rather high gain at high frequencies, and this amplifier sees an inductivity and a capacity, then he knows, okay, Thomson's law, this is a resonant circuit, and then the amplifier takes the advantage and oscillates. I will look for a similar wire with this length. I think it's a little bit longer necessary for the lower connection. The upper one is fed directly into the lower one, so I need also a short piece of green wire. The two connections to the plates, vertical plates, are soldered on. This is very close to the original version. I I checked all wires again with an ohm meter regarding continuity, and now it is ready to be brought into the scope to fix it and to plug it with this new soldered wires. The vertical amplifier is in place again. This connector is plugged. Screws are set, groundings are screwed, soldered, and on the rear side you can see it now. We have here a short green wire. You remember when we opened it, we had a loop with this blue one here inside. This acts as an antenna. Now we have the short connection direct to the CRT, to the pin of the CRT. And now we should have no oscillations. Let's check. And I can't believe what I see. No oscillations. I will connect the signal to it and see whether we can make it visible. It's 1 kilohertz. Ah, sorry, wrong one. This is the other cable. That's it, what I wanted to see. It is roughly 1 kilohertz. The trigger seems to be unstable. We still have a trigger problem. Aha. Aha. Oh. Can set the level, trigger level. That's okay. Well, looks much better. And let's go to the other channel, channel 2. This ground. AC trigger channel 2. When we do it right, then we have a picture also on channel 2. Let's increase the frequency. It's roughly 1 megahertz. Also nice. We have 1 microsecond per division. Okay, if this is. Do you see the illumination? No, the illumination is bad. Not so important. In general, it's okay now. The switches need some cleaning. Maybe they have been not used for decades as it looks. What does the component tester? That's auto setting, okay. When I go to component tester, should be the whole screen. Not so good. I'm going to make it short. Should be also the whole screen. If there is a problem, a bad contact or so, this picture should be the vertical over the whole screen and horizontal also, I think. I have to check the manual, but I'm quite sure it is bigger. But in general, it seems to work now. We don't have this odd, crazy picture what we had. Well, XY operation, reduce the, that's good. And X position is this position, and vertical seems to be okay also. In general, we made good progress. The scope is back to life. Indeed, we had a problem with the vertical amplifier with the long wires. Whoever did this has no relation to high frequency. Every centimeter is an inductivity and every centimeter gives a capacity, and a broadband amplifier with capacity and inductivity is an oscillator. Okay, that's it. I will focus now on the on the component tester. What's going on there? Why we do have such a bad contact? What it is? It's operating with a 12 volt AC. The 12 volt AC is the horizontal deflection for voltage, and via a shunt we measure the vertical deflection. That's a current, but as I know, the amplitude should be a little bit higher. And now, just for reference, with the earlier footages, we have here the output of the amplifier. That's this cable fed to the another scope, and we see that there are indeed no oscillations. And when I reduce the peak of the amplitude with the attenuator, then it follows. And when we have no input signal, nothing can be seen. Remember, we had 200 megahertz, so indeed it is clean as it should be. Now it's time to take out this board to swap the electrolytic caps. This mechanically damaged one. This one is maybe electrically dead. It's not so difficult. First I thought it's very difficult, but it's easier than I thought. These transistors can be unscrewed. They are not isolated. They're directly connected to the chassis, except this one. This is isolated. Okay, no problem. Many of the wires here are plugged. The switches can be, the axis of the switches can be removed. Also not so difficult. The delay line can be in place. This one ends up here anywhere and can be unplugged. On this side, we have to remove the axis of this pot because it is soldered to the board 2 times. There's one, the other one is here. That's the vertical position pots for the 2 vertical amplifiers. And then I think it's possible to flip it out. The board is out. It was a little bit more difficult than I thought, because the access to the screws here on the rear side where the transistors are is a little bit difficult. One screw is behind the Z board, which controls the intensity of the cathode ray tube. So this Z board also had to be taken out a little bit to get access to the screw. But I think it was a good idea, because I see beside the additional cap here some solder connections which are looking a little bit suspicious. And also here on this board I saw something. Here one pin of a resistor is not soldered. It's the horizontal output. This pin is not soldered. Here is a blob. Don't know how it came. What happened here? The power transistors for the power supply are soldered in a little bit suspicious. Some have, especially here, this transistor, there are still the holes visible, soldered only from one side. On the pad here also, this wire, flat wire here, has bad solder connections. They are not soldered properly as it should be. I have to look at the whole board carefully to see whether there are additional problems, but first I will swap all electrolytic caps. For this purpose I use my desoldering gun. It's a very useful tool. First one is out. Okay. We see, is it some acid or what is this? Or is it some resin from the soldering? I'm not sure. Let's have a look at the other caps. Now let's check some capacitors. At 120 Hertz, the first one should have 1000. Okay, it has 1000. Quality of 12. That's more or less okay. Second one should have 220. Hey, come on. Woohoo. Dead. 10 nanofarad. We have here some, as we have seen in the first sequence, something is maybe drying out. Next one should have also 1000. Okay, at 120 Hertz, 1 millifarad, that's okay. Quality factor is acceptable. It is not so important for a rectifier capacitor. Should also have 1000. Okay, a little bit more. This could be an isolation problem when there is more capacity. This one again has also 1000. Yes, 1 millifarad. This one capacitor which is damaged should have 220 microfarad. Mechanically damaged. Okay, 215. That is still okay. And this was the one which was in parallel. 220 microfarad, 100 volt. A little bit less, but it's okay. Well, I will swap them all. And then we'll solder some pins, as we have seen. And then I will reassemble it. While I was swapping the electrolytic caps, I saw this capacitor damaged on one side and mechanically damaged. I will take it out and see what the value is, and will replace it. The new cap is in place without touching any forbidden pins. By the way, this is the horizontal, the X output. These are the two connections to the X plates. So I assume it's an additional blocking capacitor for the horizontal amplifier to improve the high frequency response. Now we are at the end of part 2 of our series about the HM605. And I can promise you, in part 3, we will continue this crazy journey with or through the scope. Other topics will appear. You won't believe. Stay tuned, stay healthy. See you on this channel.